press it. Hello? Okay. So we're going to start. Sorry for the delay. Thank you everyone for being here. So this is the third edition of the blockchain workshop, which now has quite almost long history. It all started in November of last year, when at Harvard we decided to organize a preliminary experiment to a small study group of lawyers and technologists that will be interested in exploring the new opportunities and the challenge raised by blockchain technologies. And well, since then, this experiment has been really successful. We had the first real blockchain workshop conference at Harvard at MIT in January. And then eventually we realized that the discussion just could not finish like this, and that we had to keep going and keep exploring all those new technology and the new regulatory aspect that they were raising. So we're organizing the second edition in March at Stanford. And again, it seems that the more we explore those questions, then the more issues are being raised, and so we just have to keep going. So, welcome to the third edition. This one, we explored a little bit the issue from a US perspective to begin with, and then we realized that this is actually more of a global, international question that needs to be addressed more broadly. So we moved to Europe, and so welcome to this third edition. You can.
You know, in the course of doing all of these workshops, what we've really discovered is that there's an incredible community of people, and it really does take a village. This is very complex technology. It touches on, you know, every single sector of law and policy and society that you can think of. So it takes, you know, a great meeting of the minds of people with various expertise. And what's been really extraordinary is seeing, you know, how many people have been trying to tackle some of these problems and applications in their own way individually, you know, as we got into the development of blockchain, the emergence of blockchain technologies. So, you know, the strength of what's been coming out of this group, we have working groups that are, you know, working on various aspects of decentralized financial regulations, you know, what proper oversight might look like for these participatory networks, what legal wrapping and issues surround smart contracts and distributed collaborative organizations. And so, you know, the strength of this group really is because of you guys. So thank you for many of you traveling from very far to be here. And we're really excited to share what we've learned and continue to build with you guys.
And so as a little preview, we already are organizing the next workshop, which is going to be in October in Hong Kong. So if you can already clear your dates, it's going to be the internal workshop, so where we actually are going to do the real work, is on the 12th and 13th of October, and then the public conference will be on the 14th and 15th. We will send all the information as part of the debrief. And this one will be focusing more specifically on the smart contract, with the theme being smart contracts for smart cities. So, okay. Well, we can start with the opening keynote from Vlad, Zamfir, and Deitrich, demystifying the blockchain.
Our talk's called Demystifying Blockchain. And the reason is because there's been quite a lot of interest in blockchains, basically because of Bitcoin. Bitcoin is like incredibly powerful technology because it's like a program that can't get shut down. It's decentralized and like it's like internet money. So it's created a lot of hype and interest in not only Bitcoin, but in the blockchain technology more generally. So what we're going to do is try to identify, you know, what blockchains are, what innovations Bitcoin has gave us, and try to get at like a sense of what the reality is of like this technology. And I think that will be helpful for you. So let's go. So there's two innovations that Bitcoin really brought to bear in the space of distributed consensus. One of them is blockchains, and we'll get to what that is, and the other one is economic consensus. And these are actually like two independent inventions that appeared in the same protocol, and that's one of the reasons why some of this discussion has been rather confused, because wasn't already a language for speaking about either of these things, and then they both appeared in one protocol that was released by someone on the internet with a really short white paper. That like didn't really touch much on consensus, but was a lot about like digital cash.
Sure. So in an attempt to really make it practical, we're going to look at the project that we're listing here and are going through it and trying to examine what exactly from the original Bitcoin blockchain is in those projects and what inventions they have made that have added additional stuff and also left other stuff behind. And I know there are a couple of really knowledgeable people here in the audience, so if we make a mistake or anything, call us out. We're hoping for a lively discussion.
Sweet. So this is where it gets exciting, if you guys aren't already excited. So the consensus protocol is like what fundamentally all these technologies are about. And a consensus is really about making one reliable computer out of many unreliable or untrusted computers. What we have is like, we need information services more and more, and we need them to be available and to work properly. And consensus protocols are useful for this because they like use redundancy in order to like make the probability of failure much, much less. So all the technologies that we're going to be talking about are about making one reliable computer out of many unreliable or untrusted computers. So basically, and there's a lot of applications of these things. Like I said, we rely on information technology, and we're going to continue to rely on information technology. There's basically like two common classes of applications: computers on hardware and computers on a network. So like processors on a chip sometimes use consensus protocols to agree on bits. Databases use consensus protocols to redundantly store and update a database. And like flying cars, it's really important that like you're not relying on one computer to coordinate all your engines. You have multiple computers because if one fails, you don't want the flying car to like flip over and, you know, it's not very safe. It's really important to have consensus protocols. So there's consensus protocols have actually been researched long before Bitcoin brought a lot of attention to them. And basically, there's a class of consensus protocols that I'm going to call traditional consensus protocols. And the way they work is that all the nodes in the consensus protocol coordinate on adding a change to the state or making a change to the state. So they all agree on the change, and then they all change. Or more specifically, a supermajority agrees on the change, and then they all change once they eventually catch up. And we'll see that blockchains actually don't quite fit this model. But this is what like companies use on their backends, traditional consensus protocols. So basically, and these changes are never reverted. And if too many nodes go offline, or if there's a network partition, these protocols just stop because you can't coordinate with nodes that you can't communicate with. And changes are processed only if you can coordinate. So now blockchains. So blockchains, instead of coming through consensus by like coordinating on changes to the consensus, they come to consensus by like compromising on what they thought the consensus was. So we have this idea that like instead of just only appending to your list of changes, you also choose between forks of changes. So this kind of consensus through compromise is useful, it turns out. There's a couple of reasons. One of them is that it is available in the event of network partitions. And if a lot of nodes go offline, it will still go, unlike traditional consensus protocols.
Well, it's an attack vector also, right? I mean, if you have a traditional consensus protocol, if you shut off enough nodes, then everything stands still.
Yeah, so in that sense, actually, blockchains are more decentralized than traditional consensus protocols because the number of nodes that you need to shut down in order to stop it is larger. Because instead of just having to stop the supermajority from forming, you really need to take out like everyone if you really want it to stop. Of course, it's a little bit more nuanced than that, but blockchains are more decentralized than traditional consensus protocols. That's something that you should know. And then we have this like other category of consensus protocols that Bitcoin also invented. And it's independent of the blockchain, actually. But Bitcoin invented both, and that's like confused some things. So it's called economic consensus. Basically, what it does is it makes it expensive to like deviate from the protocol. It makes it expensive to like screw it up for everyone. And like this is the thing that has probably contributed the most to Bitcoin's success. The fact that it's really expensive to attack. And actually, so like, and why is this like useful to make it, you know, like literally like monetarily, like economically expensive in order to be faulty? Basically, it allows us to do this thing called public consensus. So that is a consensus between computers who don't trust each other and where they can come and go freely. So that's something that didn't exist before Bitcoin because economic consensus didn't exist. And basically, so the alternative of like, but economic consensus can also be used in private consensus protocols where someone who runs a node could be like trusted. You can have like a policy for adding people to the validator set, but they would still lose money if they're faulty.
So what's expensive in Bitcoin if you are trying to violate trust?
So I think that's our next slide. There we go. So Bitcoin uses this consensus protocol called proof of work. And the way that makes faults expensive is by actually producing changes to the state expensive. So, and then only the changes to the state that are adopted are actually lead to the issuance of Bitcoin, which compensates you for making this expensive change to the state. So blocks are hard to make because there's computational work involved in creating them. And if you created them in the right place, you're going to be rewarded for that. If you don't, you're basically faulty and you don't get rewarded. So Bitcoin, that's how Bitcoin makes faults expensive. Now there's other classes of protocols that try to make Byzantine faults expensive. This one is my favorite, which is basically by using security deposits, you could punish nodes for deviating from the protocol's expectations in any way, because the protocol controls the security deposit that's placed in the state. So that's another thing that I haven't mentioned, and now I feel like I'm speaking too quickly.
Yeah, so let me go on. So the next thing is we want to take a look at what actually motivated these different projects, because I'm sure many people would feel like I do. If you just look at this list, it's not immediately clear what's actually the difference between the nuances between the individual projects here. But the first helpful angle is actually looking at what they were invented for. So if we look at Bitcoin, it was a very clear statement in the white paper. It's really about disintermediating banks and currencies even. If we look at zero cash, that's the next step. That's an anonymous type of Bitcoin, and that's probably all we're going to say about this. Then we have Ripple. Ripple has now developed into something that's clearly positioned to replace SWIFT, which is a rather different kind of a business. So we have Stellar, which is very, very similar to Ripple in many ways, but has more of a purpose of serving the underserved. Then we have Hyperledger. That is actually a successful product used for interbank clearing. So it's really serving the banks. Then we have Ethereum. And that's going to be a public smart contract platform. We have Tendermint, and that's going to be the same, just with a little bit different implementation. I say a little bit, but from our abstract view. So then we have eris, and that's going to be a whole stack of private smart contracts platforms. So there we already have a number of distinctions between the purpose of the individual projects, and we're going to look a little bit deeper now. And if you want to explain the next core design things here, where we have the main important details, so to say, where the design of the individual projects differ.
Sure. So basically, we're going to go through all these projects again and say which of these checkboxes apply to them. So a consensus protocol is public if the membership in the validator set is like dynamic and that basically people can come and go as they please. It's private if there's like some kind of, you need to become part of a list, which is like curated by some kind of organization outside of the chain. Like that kind of, so we're going to see examples of both of these. It's good to note that all public consensus protocols are economic, but not all private consensus protocols are economic.
That's actually a little bit complicated already, isn't it? I mean, we're going to come back to that in a bit, but there's another very interesting aspect thinking about this private and public. We discussed that about whether trust is invested in the Genesis block or whether it comes later, if you want to expand on that.
Mm-hmm. So, but that's not actually a private versus public.
But
this is in an, So the authentication model of private blockchains, generally, you have like a list of nodes who you trust to maintain the consensus, and authentication ends in that list. In Bitcoin, authentication ends in the genesis block, where everyone has the genesis block as part of the protocol, and you compare the forks and how much work they have against the genesis block. So the endpoint of authentication is generally going to look different in like private versus public blockchains. But you can also have public blockchains that have authentication end in a list of validators. Again, I hope this isn't too complicated, and I'm sorry, but we're going to just keep going. So the next couple of checkboxes is like this concept of whether you have a traditional consensus protocol, one which updates, changes bit by coordination, or a blockchain-based consensus protocol, which comes to consensus based on compromise. Do you want to cover the last two?
Sure. So then we have the difference between a transaction network, where you are basically transacting money or virtual money or debt, or you have a virtual machine that's actually a little bit more like a entire programming language where you can do a lot of different things with. So if we're looking at the list of projects again now, looking again at these characteristics that we just identified. Thanks. First, Bitcoin. Bitcoin is a public decentralized blockchain, and it has a virtual machine. The virtual machine is limited in what it can do for reasons of security, but it's there. If we look at Ripple, that's a private transaction network. So it's very focused on transacting, and it has also the built-in currency conversions that are a special attribute of Ripple. So then if we look at Stellar, that's basically on that level an identical design. If we look at Hyperledger, that's a private consensus protocol. So that's very specialized. It's doing one specific thing and is successful at that, and left a lot of other stuff out. If we look at Ethereum, that again is a public decentralized blockchain with a virtual machine. And in this case, the virtual machine is certainly a lot more powerful than Bitcoin. And that is the focus. But on the design level, that is at the same level there, like Bitcoin. Then we have Tendermint, which is, again, the same. And then we have eris, which is going to be a private consensus protocol with a virtual machine. So at that point, talking about virtual machine, I would like to talk a little bit about smart contracts, because smart contracts play a very central role in lots of discussions. And I think it's possible that people understand different things when they say smart contract. What actually is a common ground, so to say, is that for actually having a smart contract, you have to have a virtual machine. And even with the virtual machine of Bitcoin, you're so reduced in your possibilities, it's quite a hassle to create stuff on Bitcoin that is more than a transaction. It works. There are projects that are quite successful in doing that because it has a lot of stuff, a lot of possibilities, but it has a very strong limitation that Ethereum is going to overcome, which is the Turing completeness of the language itself, which is why the joke is out there that Ethereum is basically Skynet, while Bitcoin tried not to be Skynet. What you should have to have interesting smart contracts is that you have a currency on the blockchain. So you really want to have this token that has value, like you have the Bitcoins on the blockchain or Ether on Ethereum, because that makes it a lot more interesting what you can do immediately through the contract, that the contract itself can actually let money flow. Another thing that we're talking rarely about, or at least what I'm witnessing, is that to do interesting stuff that's really connected with the real world, you have to have oracles. And an oracle in this case would be defined like anything that allows us to tap into the real world and real events that are going on to trigger the smart contracts in the blockchain. For that to happen, you have, for example, in Ethereum, you have to have contracts that serve as the gateway, so to say, from the outside world into the digital world and then trigger other contracts and smart contracts to do their thing. If we look at the list of projects, then if we're talking about smart contracts, it's actually these 4 that are interesting in that context. So that would be Bitcoin, Ethereum, Tendermint, and Eris. And it turns out of these 4, 3 are actually using the same virtual machine, and that is the Ethereum virtual machine, while Bitcoin is using its own rather limited virtual machine. So more about smart.
Yeah, so one of the things about economic consensus that I kind of glazed over that we should spend a little bit more time talking about is this idea that the way that we're going to make faults expensive is by using assets defined and controlled by the protocol. And so like having those assets defined in the consensus state itself is like one of the main things that Bitcoin invented. And this is also why people generally regard blockchains as distributed ledgers, even though they're not technically ledgers necessarily.
We're not going to say that word, right?
I wasn't even gonna mention the term distributed ledgers, but I'm going to do it now because just to point out the confusion. So economic consensus needs a ledger in the state. Blockchains don't necessarily. So back to you.
So now we invented these nice tags here. Going once more through this list, and the last time through this list, when we look at Bitcoin, we see that Bitcoin is actually a blockchain in the sense that Vlad defined earlier, that it has a forking algorithm, and you have economic incentive.
So Ripple is not economic because the way that malicious nodes are removed isn't by having like a cost imposed on them. It's by having them just removed from the trusted nodes list.
We didn't actually clarify whether Ripple is a blockchain or is a traditional consensus algorithm. So there's the tag missing, so to say.
Okay, but Ripple is a traditional consensus protocol because it relies on a majority or supermajority of nodes to agree on changes before they're added to the state. Stellar is like the same technology, but used for a different purpose. I mean, it's the same type of consensus protocol. It's non-economic. It's traditional consensus protocol.
Now, hyperledger is clearly a traditional consensus protocol, meaning that's not based on the actual invention of what Bitcoin did, and it's non-economic. So it's really pretty far away from what the original Bitcoin blockchain hype kicked off, but yeah, certainly part of the list that we are looking at here if we think about blockchain projects.
Yeah, there's been a lot of attention drawn to consensus technology more generally than blockchains. And that's probably like a very good thing because we're relying on information services more and more, and we need these things to make them reliable. Arguably especially for financial transactions, where we really don't want to lose the record of who has what assets. And we don't want it to be processed in an invalid way.
Yeah, Ethereum. Ethereum is clearly a blockchain, and it has economic consensus. So it's, in this respect, really building on what Bitcoin started out.
Yeah, so Ethereum's main contribution is to make it like easier for developers to use by making a VM that can be like compiled from a high-level language that they're familiar with, or that they're almost familiar with. So Tendermint is actually a traditional consensus protocol disguised as a blockchain, in the sense that it only ever it adds changes to its blockchain. It does hold the blockchain in the sense that it has blocks hashed together, but it coordinates to add changes. And as a result, it doesn't fork. So actually not having the blockchain fork is good for some applications. But it does mean that in the event of network partitions, it's not going to be available. And that, if you take most of the nodes offline, that it'll just stop. But again, so Tendermint is an economic traditional consensus protocol.
Can we dwell on that a little bit longer? You said like Tendermint is actually connecting the blocks, but it wouldn't have to.
Yeah, so technically, with a traditional consensus protocol, you don't need to chain the blocks together because you don't have to like have the integrity of forks be preserved because everyone is only ever adding to the consensus state and changing the state itself. So but it's still nice to chain them together because, you know, cryptography, yay.
But it's also the point about where the, as you say, where the original authentication is located. Because in Tendermint, you don't have to have it in the Genesis block. You actually have it in the list of trusted validators, right?
Yeah.
So that again makes it can be a blockchain, but it wouldn't actually have to be because it really relies on a list of validators that's valid right now and not when the Genesis block was created.
Mm-hmm.
And that's actually every round for every block relying on technology that uses the validators basically as source of trust and not the block before.
And there's no way that Tendermint can fork without a very large number of validators being malicious. So that we don't really have this fork choice thing, and we have the authentication not end in the Genesis block. But if we were authenticating from the Genesis block, then we would need to worry about all the different possible combinations that these blocks who aren't chained together could be ordered in. So the authentication model of Bitcoin does require the chaining of blocks.
So why is Tendermint doing that? Why is that better, or why is that progress, or is serving some?
So it does make it easier to show the integrity of the history of transactions if they're hashed together.
So what's the practical use of that? Faster block times?
You can use it to authenticate data from that was signed by the old set of validators. So as the new set of validators, you can have like a current hash, and you can make hash collisions with some ancient thing that happened with an old set of validators without having to worry that the old set of validators lied to you, because you can authenticate the past with the current set of validators. So that actually
I didn't understand that. What's the practical advantage? I mean, why would you not stay with, say, Ethereum?
Oh, so I mean, it's a proof of stake consensus protocol instead of a proof of work. It doesn't fork. There are benefits to like application developers and to people who invest in it and store in it because there's less issuance than in proof of work. So there's something there.
Okay, finally, eris. That's a non-economic incentive there. So
yeah, and rumor has it that eris is going to be switching from a blockchain-based consensus protocol to a traditional consensus protocol.
Okay, we'll leave it at that. Are there any questions, hopefully, or corrections of what we've been saying or daring to say? Please.
Excuse me. Sorry, Monday. Yeah, just wanted to quickly get your thoughts. The Isle of Man government, for example, just chose a new consensus protocol called credits. And kind of credits pretty much takes a lot of the, I guess you could say, Bitcoin, Ethereum, Tendermint models and kind of mixes it all together to provide a layer that kind of sits underneath almost, which is quite interesting and obviously quite robust. So I just wanted to get your comments on that, or if you knew.
Hey, yeah. So I've talked to Nick Williamson, the guy behind Credits, and I've talked to him about his consensus protocol. So I am familiar with it, and it is an economic traditional consensus protocol, i.e., it's a traditional consensus protocol that is turned economic. So that's how it fits into this category. We didn't realize that it was famous enough to include it in the slides, but I guess it was. Wait for a microphone.
Well, we can always repeat the question.
We can repeat the question, yeah. So just go ahead.
You mentioned proof of work and proof of stake early on. It's really related that to the different blockchain protocols. You sort of mentioned that. One of the differences, benefits and disbenefits of proof of work versus proof of stake, and also light clients for mobile devices. Which ones would be more suitable?
Okay, so let's go back to the list of projects and go through them one by one and answer these questions. And I'm not going to know the answers to all of them. I'm not sure what a lot of these projects have done to make their software more like client friendly. Oh yeah, of course. Sorry. So the question is, can we go through the list and talk about which ones use proof of work and proof of stake and kind of what that means, and also to talk about how much they've done to be light client friendly.
You might want to explain what you mean by light client friendly. I meant to be able to use it on a mobile device.
Yeah. You look for the list.
Well, we're going through the list actually, so. There you go.
Sure. So Bitcoin is a proof of work consensus protocol. It was like the first blockchain ever. So it's actually not super light client friendly, but it did do some things to make it more light client friendly, like for example, that you can choose forks by looking only at the block headers as opposed to the whole blocks. Ripple is neither proof of stake nor proof of work because it's not economic. I don't know what it has done to be light client friendly. But if you have a trusted nodes list, you can just like trust them and get a whole bunch of them to confirm. So you don't actually need to verify as much on the client side in a trusted model. Stellar, same thing. Hyperledger, same thing. Ethereum is proof of work. It's going to be proof of work on release, but transitioning proof of stake in a later release. Eris is non-economic, so we don't really say, but their like code base is moving kind of away from proof of work and more towards proof of stake kind of philosophy. And Tendermint is entirely proof of stake, which basically means that it uses security deposits to secure the consensus by making validators who propose competing changes lose their deposits. Basically, if you try to screw up the consensus, you lose money. And as far as the differences between proof of stake and proof of work, I don't know if you know, but I'm a huge proof of stake advocate, so I might be a bit biased. But proof of stake is much cheaper than proof of work because instead of paying for external resources to be consumed, you're paying interest on a security deposit, and you end up having a much larger amount of money behind it ready to be lost if things go wrong than if you pay directly for outside resources to be consumed. I don't know. And as far as light client friendliness, Ethereum and Eris are both very light client friendly compared to Bitcoin, as in there's a hash of the state in the block header so that it's easier to verify pieces of the consensus. And Tendermint also has that feature. So should we go to the next question?
I suppose I would, just a follow-up to that last point, why would it be an advantage to be able to verify from one block header as opposed to the Genesis block?
So if you need to build the state from the Genesis block, you're gonna have to process a lot of blocks in order to so Bitcoin.
Download and store it.
Yeah, you have to download and store and update these blocks. Sorry, download and store the blocks and update the state according to the blocks. Whereas if you knew the correct fork, you could just download a state and authenticate it against the hash in the header. Sorry, this is the kind of technical thing we're trying to avoid. Can we go to so maybe less technical questions?
Yeah, hi. Can you talk about the performance of each of these implementations and if you like, which ones are probably the highest transaction performance, which one would be the lowest, and why?
So as consensus protocols, they all replicate the computation on every node in the network. So the question is how efficient is the implementation and how powerful are the nodes on the network? And also, this is kind of maybe the more interesting, what scalable applications have been built on top. So basically my answer is they're all kind of the same performance from a technical point of view because they're all redundantly doing the same computations across all the nodes. Now it's probably the case that Hyperledger uses bigger servers than an average Bitcoin mining pool, but I don't know that. Architecturally, they're all the same speed, although Bitcoin has payment channels kind of rolled out, and like you can make a lot of channels payments off chain and then put them on chain. But as far as the transaction processing speed of the chain, it really there's no architectural difference between these platforms.
I mean, the closer you go to traditional consensus protocols, and the closer you go to Paxos, actually, the faster you're going to be. But to really do Paxos, you have to have low latency. So it really depends also on what the actual setup is of the computers that are talking to each other to actually perform that consensus. And for a public blockchain, it doesn't make sense to even speak of all the computers being in the same rack or the same data center. But for some applications that we have here for private networks, you would be able to have very low latency. And then the ideal consensus protocol would be governed also by that.
Yeah. So as far as what like limits the speed of these things, one of them is the network time that is required to like coordinate on changes for traditional protocols. Also, you have to make sure that nodes who are offline and come back online are able to catch up by running all the changes. So you can't actually run at full capacity. It's not going to go as fast as your web server usually goes. It's probably going to go like 10 times slower. I'll just repeat your question.
So we have seen that many people are moving away from proof of work towards consensus mechanism. So is the primary reason to do so to improve the speed?
So you mean from away from proof of work to traditional consensus mechanisms?
No, away from proof of work to consensus mechanisms.
Yeah. So what I would refer to as traditional consensus mechanisms. So the question is, well, why are people moving away from proof of work towards traditional consensus mechanisms? I think that the main reason probably is that A, proof of work is expensive, and B, traditional consensus mechanisms don't fork. And forking is like generally not the nicest thing. But I actually think that there are blockchain-based consensus protocols that are cheap, that don't fork when there aren't network partitions, but that are still available in the event of network partitions, which you can't do with a traditional consensus protocol, but you could do with a blockchain consensus protocol.
I would also say, I mean, what we're seeing also on these workshops is that there are lots of ideas coming up, and some are not necessarily blockchain ideas, but crypto ideas that use basically signature, which is one part of what the blockchain uses, but they're crypto ideas rather than blockchain ideas. And in the same vein, I got the impression that the hype, that's also a healthy thing that has developed around Bitcoin and the Bitcoin blockchain, has enabled some problems to be tackled by old technology, so to say, because traditional consensus stuff is from the 80s in some parts. So that we now see as part of the whole development that's happening, that some people go and see, okay, we're talking a lot of this problem here, but it's actually not necessarily a blockchain problem. We can solve this with these traditional consensus protocols. So then we have these projects around, we have them in the space that we're discussing, and they rightly go back and reduce the technology that's employed to what's actually needed to solve that problem. And I think that might be part of why we're seeing something that seems to look like a movement back to traditional consensus protocols, but it's just for particular applications. It doesn't make those applications that need a real blockchain or a real virtual machine go away.
Although you can put a virtual machine in a traditional consensus protocol, of course.
Sure,
Yeah.
but that's...
I agree. I guess one of the main things to stress that's good to know is that a traditional consensus protocol turned economic has this problem that like a supermajority can veto blocks, and they could basically extort people from the rest of the validator set. And actually, it doesn't even take a supermajority to prevent a supermajority from forming. So it's my view that like traditional consensus protocols have more economic problems than blockchain-based consensus protocols, because in a blockchain-based consensus protocol, you can just propose a change without preemptively having the coordination from everyone else. and then have other people kind of agree with you based on like this compromise that's dictated by the fork choice rule.
Like the damage you can do in a traditional consensus protocol, if you have a supermajority, is bigger than you can do on a blockchain protocol.
Yeah, and even if you have like just less than the majority, you can do more damage. Cool. Any more questions?
We're going to actually have our technical panel now.
Oh, yeah.
So if you have any more questions, you can ask them at the end of the next panel. So thank you very much.
Thank you.